Okay, everyone, welcome to our Introduction to Networks class meeting today. We're going to do a couple things today. It's going to be a little different. One is going to be I'm going to actually use my service tablet so I can write on some of the different slides and show you some things. I want to start out with a quick review of IP addressing and what we talked a little bit about last week, where we talked about what IP addresses are, how they're 32-bit addresses that we look at in dotted decimal format. What we do when we're looking, the neat thing about this is, hopefully that's, yep, there we go. All right, so undo. We've got the ability to look at IP addresses as a series of bits or in dotted decimal. So when we do 192.168.12.100/24. One of the things we need to look at is we need to always look at, and I apologize, folks, but I am left-handed. So if my handwriting is horrendous, it's because when I was in kindergarten, they tried to make me write right-handed, and it didn't work. So this is why I didn't. So we have this dotted decimal format. This shows us that by default, if we're using what is called classical addressing, what type of address would this be? What will we consider this to be? I'm going to pull my chat down so everybody wants to just type in chat instead of. What class of address is this? A 192.168. Using old classical address.
Class C.
It's a Class C because of the 192. The fact that it begins with a 110 in the first octet, the first 3 bits are 110, and then it has the value of 192 to 223 in the first octet. That is a signal that it is a Class C. In this case, we also have a subnet mask here that's associated with it, which is the default mask for a Class C. What does this last 24 mean?
24 bits that you're using.
Correct. 24 bits in the mask. Sheila's saying she can't hear me speak. Anybody else not hearing me? Sheila can't hear me, but anybody else? I think, George, you're definitely hearing me. Ethan, can you hear me?
I can. Can you hear me?
I can. Reva, you can hear me too? Joseph? Okay. So it is 24 bits in the mask. So it's 24 bits that are turned on in the mask. In other words, there's 21 ones, which translates to 255. Oh, Lord, I can't type. I can't write. 255.255.0, which also tells us that we do have audio, but it's only through voice over IP. If you connect via telephone, there we go, right? You've got to call your computer. You've got to tell your computer to call. I'm only using voice over IP. So with this mask of class 24, we've got 24 ones turned on in the subnet mask. Remember that a subnet mask, its entire purpose is to tell you what part of an IP address is the network portion and what portion is the host portion. With a /24, that tells us that the first 24 bits are network or subnetwork bits, and then the last 8 bits are the host bits. So these should be host bits, and then we have in network bits there. So we can look at another IP address. Let's imagine 10.0.0.1/24. And that tells you a very different story. It's still the same thing that we have 24 bits that are network bits, okay? And what we're actually going to learn is that these are network. And then we've got one set of 8 bits. So this is obviously a Class A address. That's also in what we call the RFC 1918 addresses, or the reserved addresses. So we can look at an IP address and a prefix and determine what portion is the host and what portion is the network. Where we're going to get into trouble, and this is where things get kind of weird, we're going to get into trouble when, I'm going to not say this. Where we're going to get in trouble is when we try to set up a network in the following situation. Now let's imagine we have this network. Okay, we've got a router. We've got another router connected via serial cable, and we have two switches. And again, I apologize for my drawing. I am not an artist. All right. And we have this network. Somebody hands us 192.168.12.0/24. Now, what's the problem with this? Let's examine what we have. This is a single network, the 192.168.12.0 network. So, up to 254 hosts, because our host bits are from 1 to 254. Remember, we can't use .0, because that's where all the host bits are zeros, and we can't use 255, because that's where all the host bits are ones. Well, this network that I just drew here, this network requires more than one network. We've got to have a network for this interface, okay, which could be a gig 00. This is a serial 001 or 000, and this is serial 001, and then this could be a gig. So when I look at this particular setup, and we'll say gig 01 and gig 01. If I look at this particular setup, I need three networks, one for each of the Ethernets and one for this, and this is where people get confused. This is a shared network right here. So this is a point-to-point network, okay? And so we need three networks, but my ISP only gave me one network. So what am I going to do? What can I do to fix this issue? Anybody have an idea? Subnet. Yep, that's exactly right, George. We're going to subnet. Now, what is subnetting? The book definition of subnetting is borrowing host bits to increase the number of network bits. Now, the book doesn't really teach subnetting the way I do. I'll be quite honest with you. I've developed a scheme here that I come up with. There's my schedule for the week, by the way, to give you an idea how busy the week is. But here's the I'm going to show you the 7 holy steps of subnetting. These are, and I will send these out to the class, but these are the 7 steps that I came up with of doing what I call traditional subnetting. Now, this is not DLSM. This is not applying subnetting in the most efficient fashion. This is learning how to take a network and subnet that network. We will become proficient with DLSM once we understand this type of what I call traditional subnetting. I also, folks, strongly recommend that you teach your students this traditional subnetting first, then present Chapter 8, which Chapter 8 is looking at just doing prefixes, so borrowing certain pieces and putting them in with DLSM. If you use these 7 holy steps of subnetting I come up with, these steps will give you subnets that are all the same size, okay? So again, they're not going to be efficient, but they're going to be able to be used. Students can kind of come up with ideas about how to better apply subnetting using DLSM. So let's look at these steps. First off, I got to determine the number of needed subnets. So let's pop over here. I've already told you we need a subnet here. Okay. So basically, every router interface is going to need a subnet. This is going to be one subnet though because it's a shared point-to-point interface. And then we need another here. So we need 3 networks, but my ISP only gave me one network of 254 hosts. So this will not work as it has been given to me by my ISP. So step 1 was determine the number of needed subnets. Step 2 is right after host bits. Now later on when you get proficient, you really don't have to do this. I have my students do it though because it allows them to see that, remember, subnetting is the process of borrowing host bits in order to, I'm going to suppress this real quick, folks, in order to turn off all my mess with my things here. So that way we won't be bothered by that again. Okay. But subnetting is the process of borrowing host bits in order to get more network bits. So in step 2, I have my students go and look and say, okay, how many host bits do I have in this network? I have 8, so I'm going to write out 8. And now it's not wanting to write. Okay, so we can make that work. So we go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So we've got 8 host bits. So now we're going to look at step 3. So we got 8 host bits. Step 3 is determine the number of bits you need to borrow in order to get the needed number of subnets. Now the formula is 2 to the n. 2 to the n equals number of subnets. And n equals number of borrowed bits. Okay? Again, I apologize for my horrendous handwriting. If you were in the classroom with me, you'd get the exact same handwriting, so it's not really much better or worse. The sad thing is I was paralyzed from the neck down after my accident last year when a truck hit me, and my handwriting still just it's about the same. There's no difference. What I have a lot of times my students do is the following. I have them write this in the classroom on their sheet, or even when they go to take the certification test, you know, you've got a little sheet of paper that you can write down what you want to write down before you start. And so you can actually go in here and just put this on the side so that you don't make a dumb mistake, which I will make dumb mistakes in math. So this is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and 2048. So we need 3 subnets. So how many bits are we going to need to borrow to get at least 3 subnets? Anybody? 2. 2. Yeah, because 2 to the second power equals 4. So we're going to end up with 4 subnets. So we won't be exactly just 3, but we will be able to use 3 of the 4 for this. So now, step 4 is turn on the number of bits that you borrow. So we're going to turn on 1, 2, 3, 4, 5, 6, 7, 8, and find the decimal value. What is the decimal value of that?
192.
That is 192. 192. That's a 9. What about that? Hold on a minute. Look at this. I can erase. 192. So we now have in step 5 of our subnetting, we now know our new subnet mask. Our new mask is the value that you borrowed from the 456 plus the original mask. Our original mask was 255, 255, 255.0, but now we borrowed 2 bits, so know the new mask is 192, and our new slash notation is /26. We then need to figure out what our ranges are, and we do that by finding the least power bit turned on and finding the value there. What is the value of that bit position?
64.
Correct. That is 64, okay, because it's 2 to the 6. We then take that to find our ranges, and our ranges are 192.168.12.02. Now, our range is 64 in size, but 0 is considered a number, so it's 0 to 63. 64 to what? 127, then 128 to 191, and then 192 to 255. So what we have done here is we took one network that our ISP gave, the 192.168.12.0/24 network, and we have subnetted this by borrowing 2 bits that we now have 4 subnets, and it's 2 through 3. You can now, folks, go in and actually apply these subnets to interfaces. So right here, we can put the IP address of 192.168.12. What's the first usable address in subnet 0?
1.
Dot 1. Now, what's my slash notation again? Remember, it's got to be slash 26 because we borrowed 2 bits. And then we could come right here and we could put dot 65 and dot 66, both again slash 26, slash 26. And then way out here we could do dot 129 slash 26. And now we've used these 3 subnets to meet our requirements for this network. Now, is this the most efficient way of doing it? How many hosts do you have on this subnet right here between the 2 routes? This is a point-to-point link, so how many IP addresses are you going to have? 2. 2, yeah, because there's this here to here. So this is not the most efficient way to subnet because I put a subnet that consists of, by the way, let me ask you this. How do I determine how many hosts are on each subnet?
2n minus 2.
All right, I actually use 2h minus 2. And the reason I do that is because h is the host bit.
Right.
And I know a lot of books will use 2n minus 2, but I actually do 2h. I teach that to my students where h equals the number of host bits. So in this case, what do we have? How many host bits do we have left when we borrow 2?
6.
So 2 to the 6th minus 2 equals 62 usable hosts. So I created, from one network, I created 4 subnets of 62 hosts. Now, it's a huge waste right here in the middle. That is a case of how we can do subnets. Now, I'm going to close this and go back over here a second. I'm going to show you something. So using the 7 holy steps, I determined the needed number of subnets. I wrote out my 6 bits. I determined how many bits I needed to borrow to get the needed number of subnets. I turned on ones or set to ones the number of bits you borrowed and got the decimal value of the octet. Got my new mask. Found the value of the least outer bit turned on. That was my variable. And then that became how I created my ranges. So let me go back here a second. I'm going to do something. I'm going to take the same network, but let's do this. Okay. So let's imagine I've got the same network, but I need 10 subnets. Okay? So step 1's already been done for you. I've told you you need 10 subnets. What was step 2? Write out your host bits, right? That has not changed. So it's 1, 2, 3, 4, 5, 6, 7, 8. Step 3 is determine how many bits you need to turn on or to borrow in order to get your needed number of subnets. For 10 subnets, how many do you need?
4.
And borrow 4, so it's 2 to the 4th equals 16, right? So we're going to borrow 4. So it'll be 4 bits we borrow. Step 4, we're going to turn them off. 1, 2, 3, 4, 5, 6, 7, 8. Find the decimal value. What's the decimal value?
16.
Nope. It's
For the
plus 64, 240. So step 5, that's step 4. What's our new mask then? Correct. You take the value you found up in step 4, and that becomes the value there. Now we've got to find our variable, so we'll go back up and look at our variable right here. What is it? 16. So now we can do our ranges. So our ranges are 0 to 15, 16 to 31, 32, this is where I always get in trouble here, 47, 48, and so on and so forth. So I can continue to write all these out. But we're going to end up with 16 different subnets. How many hosts are on each subnet?
14.
Yep, 14, because it's 2 to the 4th minus 2. So it's 16 minus 2, which is 14. Now, here's a key concept. With subnetting, because by its very nature, it is borrowing host bits to increase the number of network bits. Every host bit that you borrow decreases the number of hosts on that network, because you're reducing the number of host bits. You can never borrow more than a slash. Okay. For the purposes of the CCNA, I'll say that. You can never borrow more than slash 30, okay? Because you've always got to leave at least 2 host bits, because 2 to the 2 minus 2 equals 2, right? So if you don't have at least 2 host bits, you would not be able to have any hosts on the network. That, by the way, will be the subnetting scheme that we will use when we start using doing serial links, cross serial links. Now, are there any questions so far? Again, this is standard subnetting. I sent you a video on this that I had done on my YouTube channel where I went through the 7 holy steps of subnetting. One of the things I want you to be aware of as we look at this, I'm going to do a new file here. Do a new one. Let's imagine you had this 10.0.0.0/8, and I said that you needed 4 subnets. Now, it gets a little weird, but it's still the same thing. Step 1, you need 4 subnets. Step 2, how many host bits do you have?
24.
Yeah, you got 24. This is where I told you I wish I had $1 for every time I put a 0 on a page or on a board. Or a 1 or a 0, I'd be rich. 1, 2, 3, 4, 5, 6, 7, 8. All right, so you got 24 host bits. How many bits do you need to borrow to get the needed number of subnets?
20.
Nope. You only need 4 subnets. Remember the formula is 2 to the n equals.
You just need 2.
You just need 2. That's exactly right. That has not changed. So we're going to borrow 2 bits and turn them on. Now this is where it starts getting a little weird. 1, 2. This is step 4, by the way. 3, 4, 5, 6, 7, 8. And by the way, if you'll just humor me, I'm just going to put .0.0. Okay. Convert this to binary or to decimal. Yeah. So what's my new mask in step 5?
5.192.00.
Yep. 5.192.0.0. Now the only thing that changes when you go from a class C, traditional class C, to a class B or A is step 6, and that is you have to find the variable in each octet. So what's the variable, the least order high order bit turned on in octet, the second octet?
64.
Okay, so the variable is 64 in the second octet.
Right.
What is it in the third and fourth octet? It's actually 0 in those because we didn't borrow anything.
Right.
So the third and fourth octet is 0. So now we've got to find our ranges, and we always start with our major network number, 10.0.0.0, okay? And then we go 10. Now what was the variable in the second octet?
64.
All right, so it'd be 63.255.255. So in other words, we didn't borrow anything at all from the third and fourth octet, so we just roll them by their full value. Then we'll come back here and go 10.64.0.0, 10.127.255.255. What would be my next range?
128.
128.0.0 to 10.191.255.255. And then our final range would be 10.192.0.0 to 10.255.255. 255, 255. And you'll notice I took this one network, okay, of a whole bunch of hosts, okay, and I've created 4 networks or 4 subnets of also a bunch of hosts, but they're smaller. And this would be the type of thing I could then, this would be for all my networks in Atlanta. You know, this would go to Chicago, because I would then subnet it further as we go along, and so on and so forth. So I could put these out to different cities if I was doing a large implementation and be able to roll it out. Okay, does that make sense? This is the single most important thing in all of Introduction to Networks. All right, she was saying no. Okay. Well, let's go back one more time. Let's go back to a class. See if I can't go back. Let me go back to a class B. Okay. By the way, when you start looking, oh, you said yes. Okay, yes. Oh, she said yes. All right, GG. Now, sometimes I give you numbers, sometimes I don't. You also realize that there are occasions when you just have a network and you have to look at it. And there's my serial interface first. These are switches. I know, they're oblong switches. So tell me, how many networks or how many subnets would I need in this particular? 7. We got a 7 here. Okay, let's see, we got 1 here. We got a shared one here, so there's 2, 3, 4, 5, 6, and 7. That is correct. Okay? So it's important that you can look and see that each interface on a router does need to be in a different network, and then you can also go in and figure out the number of subnets. Now, again, what's the major problem with using 7-hole nets? You end up with all your networks the same size, and that wastes a great deal of space on your network. So let's imagine we have something like this. Okay? Let's imagine we're back to our same network here. We got a router. And let's just put back where we were. So we've got this. So we know we're going to need 3, right? But we need different sizes. We need this one to support 100 hosts. This one to support, how many hosts do we need right here between these two? 2. We just need 2 hosts. And let's say this is only going to be 10 hosts. Well, if I use standard subnetting, I'm creating, in fact, I really can't easily do it with standard subnetting because I need 100 hosts on this particular network. So let's imagine I've got 192.168.12.0/24. So I've got a network that is 24 bits in size, which gives me 8 host bits. We're going to just borrow 1 bit, /25. Now, what is the variable at /25? It's 128. It's 128 because if you just turned on 1, if it's 1, 2, 3, 4, 5, 6, 7, 8, the 128 is turned on. So our variable is 128. So it's 0 to 127 and 127 to 255. So we created 2 networks, 2 subnets that we pulled out from that particular range. Now, how many hosts are in each of those? That's 128. There's 126 usable hosts in each one of these. So since I need 100 hosts here, I could actually come right here and say that I'm going to put 192.168.12.128/25 right here. Okay? So that pulls out this one, and it's done. I can't use it anymore, right? Then I need another network with 10 hosts. So let's go right here and do /26. The variable there is 64. So we break the 0 to 127 down to 0, 63, and 64 to 127. You notice I'm not making numbers up. I'm just taking the networks and breaking them down by the value in that bit position. Get rid of that dot there. Okay. Now this still has 2 to the 6 hosts in it, so it's still a little big. It's still got 30 hosts on it. So I could then take and do a /27, break this down, okay, 0 to 31, okay, and 32 to 63. All right. Now that's still too big because it leaves us. We now borrowed 1, 2, 3, it's 2 to the 5th. That leaves us with 30 hosts per network. So we can actually keep going to /28, and this becomes 0 to 15 and 16 to 31. Right. Now I can pull this network out right here. 192, 168, 12.16/28. And then I can also just go ahead and pull out for this network that just across this host 192.168.12.0/30, which is basically me taking this one all the way out /29 and then /30. You notice now this is VLSN, variable subnet masking. We have a /25, we have a /28, and a /. You have to support those items. Your protocols must support the ability to do this. Is this making sense, everybody?
Yes.
Okay. I'll send this out, the submeeting. Again, I don't want to bore you to death, but I do think it's very important that you see that the chapter doesn't really use this older style of subnetting. It tries to go straight into prefixes, which is fine, but I really think it's important that the students understand the older way of doing things, and then they can see where it's coming from and then start using prefixes. Now, large broadcast domains, I'm going to spend a little bit of time on this, but broadcast domains are all the area within which a broadcast will affect users. The bigger the broadcast domain, the more problems you can have with traffic in terms of having to deal with the broadcast. Remember that switches will send a broadcast out all ports except the one it came in on. So we typically use routers to break up broadcast domains. Again, here's our subnetting. It could be, we could subnet based on location. So here's a different subnet for each floor. Here's a subnet based upon I'm going to mute you real quick because I'm getting background noise on. We've got, accounting. We've got students, administration. So this is for security reasons. And then we can do it by device type. So all hosts are on one subnet, all servers on another, etc. It just depends on what our particular design is for our network. For us, for instance, here at Stanley, we subnet based upon, number one, we subnet based upon the building you're in. So there's a range of addresses that are in your building. And then each individual room has a subnet that's a /24. So we can do continue to subnet down to the levels we need. These are the octet boundaries. So this is really looking at it from a class A, B, and C standpoint. So looking at typical subnetting boundaries that we've used here. This is subnetting /16. You notice that immediately go to /16. This all the networks are the same size. And some of what I was doing with you is it's quite a simple because of the fact that it's going with a /8 to a /16, so they started with a class A. This is taking a 10 network or a /8 all the way down to a /24, which is one of the more useful ways of using the RFC 1918 addresses for 10. It's taking it all the way down to a /24, so giving you a large number of what appear to be class C size subnets. You'll notice here are all of the possible ways you can subnet a /24 network. So you can borrow between 1 and 6 bits. Okay. you've got 128, 192, 224, 240, 248, 252. That's 7 bits. 2, 3, 4, 5, 6, up 6. You've got the ability, you see, of 2 subnets with 126 hosts, 4 with 62, 8 with 30, 16 with 14, and that is using, again, that exact same thing I said before. You've got number of bits you borrowed. It's 2 to the n equals the number of subnets. So 2 to the 1 is 2, 2 to the 2 is 4, 8, 16, 32, 64. Okay. And they call it the magic number, getting the magic number. I call it the variable, so that's what I use. So here's classes. We're going in here and talking about doing it with classes, so they're actually borrowing 1 bit. This is exactly what I just did with you a second ago. I borrowed 1 bit, and then that gave me the first set of subnets. Then that gives you 2 subnets. From here it gives you the 0 to 127, 128 to 255. Then you can take that, borrow again, and go on and so forth. /25 topology, they're just walking you through, once again, getting the ranges, which is using that variable. Notice again, and this is very important, this is something to make sure your students understand. When you borrow that 1 bit, okay, so this is the position right here, the bit position that you borrowed. Notice this is why you can't use 192.168.10, because all the host bits here are zeros. You can't use 192.168.1.127 either, because here you see all the host bits are 1s, and host bits cannot be all 1s or all 0s. It used to be, and you may have been taught years ago, that you couldn't use subnet 0. If the subnet value or the network value was 0, you couldn't use it. That's no longer true. Pretty much all networking equipment, modern network equipment, can support subnet 0, so that's not an issue anymore. Subnetting formulas here again, 2 to the n equals the number of bits borrowed. That gives you the number of subnets that you will have. And then for the host, I do 2 to the n minus 2. I use 2 to the h because I think it's a little easier to understand. So again, they just walk you through. Now we're going to create 4 subnets. We borrow 2 bits, and so they walk you through the process of doing that on each with a class C for each one. And I do like this. I do like that they show you actually putting the IP addresses on the interface. Make sure your students don't forget to put the correct mask, because it is the mask with the IP address that determines what network you're on. Let's see. Give me a chance. Bill's saying he can't. Look at that. Okay. All right, they click on it. Really? Okay. All right, we'll look at that in just a second. But we'll look at that once I get done recording. I'll look at it. Okay. And this goes through more demonstrations showing you how to do /16s, and this is subnetting /24 using prefix lengths up into the 3rd octet instead of the 4th octet. And then calculating the host using that 2 to the h minus 2. And that's creating 1,000 subnets with /8. That would just be borrowing up to 10 bits. Plus 2 to the 10th is 1024. And you go all the way down and say, okay, we're borrowing 10 bits. So we borrow that. We find the value of the 3rd octet. The variable is 1, or the magic number. In the 2nd octet, or excuse me, the 2nd octet, the value is 1. In the 3rd octet, it is 64. And then the 4th octet is 0. Then we would roll those by that particular value. So you've got 10.0.0/18 to 10.0.64.0, and then all the way down. And it would be actually from 0 to 255 in the final octet. But you see it's going, you got to roll the 3rd octet here all the way down through 255, and then you hop over to the 2nd octet and use the variable of 1. And that would continue all the way through for all 1,024 subnets that you create. And your host would still be the same, be 2 to the h minus 2. So we can subnet based on host requirements, so the number of hosts we need, and that's where we kind of get into VLSM, looking at the number of hosts that are needed on a particular network. And that, folks, is traditional subnetting and how it wastes a large amount of addresses. Okay. Then we move into BLSM, which I've already talked a little bit about, how we can set up a network using varying sized subnets. So we can take, and all BLSM is subnetting a subnet. So when I went through that process a while ago of actually just going through and breaking out this network into multiple pieces, you know, going from /24 to /25, /26, all we're doing is breaking the network down into more subnets. So that's the subnet, obviously. Okay. And so BLSM is just taking that subnet and subnetting it further. 063, 64 to 127, okay. 128, 191, and 192, 255. So we just broke these into smaller portions. So that's all BLSM is, subnetting a subnet. And then pulling out the pieces you need and making sure you don't accidentally assign the same pieces to multiple things. So see, you can see here, with this particular setup, you can use /27 for the LANs, and then /30 for the WAN connections, those point-to-point connections, to give you two hosts. So basic subnetting wastes a large amount of addresses, but if we use, now I will tell you this is something I don't particularly agree with. And it completely depends upon your organization. But when you do the packet tracers for this particular chapter and when you work on some of the labs, they expect you to pull your WAN addresses out of like the final range. Many places only pull them out of the beginning. And the reason that is they would rather use these for the LANs and then take down here because you've got .0/30, .4/30, .8/30, .12/30, and that way you know it's always 0, 4, 8, 12, 16, 20, 24. So the curriculum does it backwards. They take the final subnet and subnet it for the WAN links, and I don't agree with that. And I think it's a little more difficult, and I also think that in most modern networks you have people using that .0 network that they break down for their WAN. If I'm wrong, tell me so in chat, but that's what I've seen most of the modern networks I've seen them work on. So be aware when you're doing the PTs, that can be something that gets put out there. All right, I'm going to, here's a BLSM chart showing you different hosts and different things. I'm going to just move on through here. And there's a lot of videos you can do and a lot of practice. One of the things about planning IP addressing is make sure that you plan for growth. Networks are like rabbits. If you got 10 hosts today, you'll have 20 tomorrow. So be aware of that. Also be aware that with BLSM, there are things that we'll talk about later, and we're going to talk a little bit about doing what we call aggregation, or basically CIDR, classes under domain routing, where we're going to look at being able to summarize networks together, and we'll talk more about that as we move forward. Okay, folks, what I'm going to do now is I'm going to stop sharing my desktop. I am going to stop the recording.